In this lecture, we will be discussing some practice problems in the topic three-phase circuits. This is the first lecture in this section. First problem. A balanced three-phase load has per phase impedance of 30 plus J50 ohm. If the load is connected across 400 volt three-phase supply, find phase current, line current and power supplied to load when it is connected in star and delta. So we have to consider two cases, star connection and delta connection. So these are the two possible connections. First one is star connection and second one is delta connection. So in all the two cases, the impedance is connected in all the three phases. It said all the three phases are equal and is equal to 30 plus J50. In the question, the impedance is given in rectangular form. So for easiness of calculation, we are converting the impedance which is given in rectangular form to polar form using the scientific calculator. So it is obtained as 58.31 angle 59.04 ohm. Now let us consider the first case, that is star connection. In star connection we have to find the phase current, line current and the power supplied to load when it is connected in star. In star connection. So in the question it is given that the line voltage is equal to 400 volt. So line voltage is equal to 400 volt. Line voltage means voltage across any two phases. Then in a star connection, the relation between line voltage and phase voltage is given by phase voltage is equal to line voltage divided by root 3. So it is equal to 400 by root 3, which is obtained as 230.94 volt. So we have the phase voltage. Phase voltage means voltage across neutral and any of the three phases. This is the neutral line. Voltage across the neutral and any of the three phases will give you the phase voltage. Now we will calculate the phase current as well as line current. So phase current is equal to phase voltage divided by per phase impedance. So phase voltage is obtained as 230.94 angle 0 divided by per phase impedance is obtained as 58.31 angle 59.04. So it is equal to 3.96 angle minus 59.04 degrees. This much of ampere. This is phase current. And in the case of star connection, line current is equal to phase current. So we can write line current is equal to phase current is equal to the same value obtained earlier. Next you have to calculate the power supplied to load. So the equation for three-phase power is equal to root 3 VLIL cos phi. So the values are available, VL, IL and phi. Root 3 into VL is 400, IL is 3.96 and phi, the phase angle, is equal to 59.04. So it is equal to 1411.4 watts. That is the final answer for star connection. Now let's consider the delta connection of the same impedance. So here the same impedances are connected in delta. So in delta connection also, in the question it is given that line voltage is equal to 400 volt. But in the case of delta connection, line voltage will be equal to phase voltage. That is the voltage across these two lines or these two lines or these two lines. So it is equal to 400 volt. So in order to find the phase current, I phase is equal to V phase by per phase impedance. It is equal to 400 volt divided by 58.31 angle 59.04, which is equal to 6.86 angle minus 59.04 degrees. That is much of ampere. So we have the first section I phase. Then next we will find IL, that is line current. Line current is equal to root 3 times phase current in the case of delta connection. So it is equal to 11. By substituting the value of I phase, you will get 11.88 angle minus 59.04 degrees. Next we will find the power supplied to load, that is equal to root 3 VLIL cos phi, and here the value of VL is the same, that is 400 volt. IL is equal to 11.88 and phase angle is the same. So the power supplied to load is equal to 4234.2 watts. That is the final answer. Next, we will discuss the second problem. Here, a balanced three-phase star-connected load of 150 kilowatts takes a lagging current of 100 ampere with a line voltage of 1100 volt at 50 Hz. Find the resistance and inductance of the load per phase. So here we can see that the impedances are connected in star and it takes a lagging current. That means the impedance consists of a resistance and inductive reactance. We have to find the resistance and inductance of the load per phase. So first of all, let's see the connection. Here we know that it is a star connection. Now let's write all the available values which is given in the question. In the question, power supplied to load is given as 150 kilowatts. That means 150 into 10 raised to 3 watts. And line current is given as 100 ampere. And line voltage is given as 1100 volt. So we have to find the resistance and inductance. So first of all, let's write the equation for power delivered to load, which is given, which the value is given in the question. So power delivered to load is root 3 VLIL cos phi. VL is given, IL is given. So you can find the cos phi by substituting the values of P, VL and IL. So we have substituted the values, available values. Then now we'll find the value for power factor cos phi. So cos phi is equal to 0.787 by solving this equation. Here a power factor in the impedance triangle, you can see that cos phi is equal to R by Z. Cos phi is equal to R by Z. So if you find R and Z, you will be able to find the inductive reactance also. So cos phi is equal to R phase by Z phase, where R phase is the per phase resistance and Z phase is the per phase impedance. Now we have the equation Z phase, per phase impedance is equal to per phase voltage divided by phase current. Phase voltage is equal to, in the case of a star connected system, phase voltage is equal to line voltage divided by root 3. And in the case of star connection, we know that phase current is equal to line current. So by substituting the values of VL and IL, we will get per phase impedance as 6.35 ohm. So we have the per phase impedance. Now we look at the impedance triangle. You have impedance, you have 5. Then we can calculate resistance. So resistance R phase, per phase resistance is equal to per phase impedance into cos phi, because cos phi is equal to R phase by Z phase. So it is obtained as 5 ohm. So we have the per phase resistance equal to 5 ohm. Now you have impedance and resistance. So it is easy to calculate the uh, inductive reactance. So inductive reactance per phase, XL phase, is equal to square root of Z phase square minus R phase square, which is equal to 3.91 ohm. So you have obtained the inductive reactance per phase. In the question, it is asked to calculate the inductance. So inductance is equal to inductive reactance divided by 2 pi f, which is equal to 0.012 Henry. Thank you.